All right, so simplifying radicals. It says Sage purchases a caravan that has a square window uh, with side length X. If the window has an area of 144 square inches, write an expression to represent the side length of the window, then simplify the expression. Okay, so let's say this is our window. Each side is X. The area is 144 square inches. And we want to find that length. The way we would find it, X equals the square root of 144. Okay. So how long is each side of that window? How many inches? Oh, 12 inches long. A square roots are examples of blank expressions. Starts with the R. We talked about it before. Radical. Radical expressions, and they're often used for solving quadratics. Well, definitely that's what we're going to use them for. So an expression with a blank sign, with a radical sign, if no root, okay, let's do this first so we know what we're talking about. Starting with, what's that type of symbol called? It's a radical. And this is this whatever number we have here, it's the root index. We usually call it just the index, but the official name is root index. How about the number inside the square root? No, that's for exponents. It's kind of similar to, if this was like the division symbol, what did we call the number inside? Dividend. This is called the radicand. Yeah, I thought it was a funny name myself. Radicand. Okay. Um, so now that we have all of that, if no root index is shown, such as this example, it is assumed to be 2 or a square root. So usually for square roots, we don't put the little root index of 2. We just leave it blank. Okay? When simplifying a square root, list the principal or positive square root. Okay, guys. So this is a very important concept here. Um, when you're finding a square root, like the square root of 49, it actually has 2 answers. 7 and negative 7. We've talked about that before. But we always list the principal square root. Just 7, the positive answer. When we start solving equations with this, we are going to list both answers, the positive and the negative. Kind of, this is why when we start using this quadratic formula, there's a plus and a minus. Because we're going to have a positive and a negative square root we're going to look at. Okay? All right, but for now, we'll just work with the positive ones. So let's start with this. This is basically what we're going to be doing. To simplify expressions, we can use the product property of square roots shown below. So the product property of square roots is this. If you have the square root of a product, a times b, you can break those out into two separate roots or square roots. Square root of a times the square root of b. Okay? And we're going to use that fact right now. So first of all, what's the square root of 100? 10. So we're going to rewrite square root of 100 as a product of perfect squares, because there are two perfect squares that multiply to give you 100. So here it is. So basically, we're going to start with the square root of 100. They didn't show you that. I don't know why not. And that's going to break up into the square root of 25 times the square root of 4. The reason we chose those is they're both perfect squares. And later on, we're going to be okay with just having at least one perfect square. But here there's two. That's great. So that means we can use this product property of square roots and break it up into square root of 25 and the square root of 4. And the square root of 25 is, and the square root of 4 is 2. And 5 times 2 is, so we got our answer directly. Square root of 100 is 10, or using this long process to get the same answer. It's just showing you that you can break it up and get the same answer. This is definitely the longer way to get there. But you'll see why we need to know the skill in a little bit. So a square root radical expression is simplified when the radicand or the number inside the radical sign has no perfect square. And their factors are other than 1. So here's what we're talking about. The square root of 15 is in simplest form because none of the factors of 15 are perfect squares. Think of the numbers that multiply to give you 15. 1 and 15, well, and 3 and 5. None of those are perfect squares, right? 12 is not in simplest form because one of the factors, to be specific, 4 is a perfect square, right? 4 times 3 is 12. So let's complete this list of perfect square numbers so that we can see how this is going to work. So let's just write the answer. 2 squared, 4. 3 squared, 9. 16, 25, 36, etc. And just 64, 81, 100. And probably at this point, sometimes it's good to have a little calculator handy. Do me a favor, if you're in the front row, pass back those calculators so everybody gets one. All right. So let's start with 27. in the square root of 27. Let's write the factors. I always start with the easy ones, 1 and 27, right? Are either of those perfect square numbers? Mm-mm. What other factors do we have? 3 and 9. Are either of those perfect squares? Yeah, we got 9. So the answer for simplified would be no. We can break it up and simplify it. Okay? And we'll do that in a minute. Okay? Let's try the square root of 38. Well, the number 38. We got 1 and 38. 2 and 19. Anything else? I believe that's it. Any of these numbers, 1, 38, 2, or 19, any of those perfect squares? No. This one would be a yes. It's simplified. We cannot break it down anymore. Okay. So now let's try 125. Well, we got 1 and 125. Well, certainly 5 is going to work in there, right? 25. Anything else? Anything else? 3 and what? Well, 125 divided by 3. Do we get something that... No, we don't, right? I think that's it. I just put the comma at the end thinking there was, but I can't think of anything, and I think that's it. Any of those perfect squares? 25. 25. So this would be a no. So now, this is probably getting ahead of ourselves, but just let me show you why we need to know this. For the ones that are no's, let's go back to those. The first one and the third one. Okay? This is what we're going to do. You're going to break up 27 into 9 times 3, right? Then we're going to use the product property we just talked about and break this up into the square root of 9 times the square root of 3. Okay? Now, what's the square root of 9? 3. So your final answer, 3 times the square root of 3. This is your simplified answer, 3 radical 3. Okay? We just simplified this square root into 3 radical 3. Okay? Let's try that. I'd like you to try that with number 3 there. Let's break that one up. So which are the numbers we want there? Okay, 5 and 25. So I'll put 25 first because I know that's the square root or the perfect square. So this is going to break up into square root of 25 times square root of 5. And the one we can simplify further is radical 25. It becomes 5. So this is 5 radical 5, or 5 square root of 5. Okay? Yes. No, it just kind of happened in these two examples. You may have 4 radical 3, 7 radical 8, or yeah, stuff like that. Okay, you guys ready? So basically what happens next is what we just talked about. All right. So we're going to find the largest perfect square factor in the radicand. Then we're going to rewrite the radicand as a product using perfect square factors and the product, like we just did, or the product property. And then take the square root of any perfect square. So we're going to do that with 24. Okay. So 24, we can break that up into two numbers where one of them is a perfect square, right? The square number 24. What two numbers where one of them is a perfect square multiply to 24? 4 and 6. So basically, that's what would go here. 4 times 6, which breaks up into square root of 4 times the square root of 6. And we all know the square root of 4 is 2. So the square root of 24 equals 2 radical 6. Okay? So let's practice that here. So let's start with 48. Think of factors of 48. Remember, we want the largest. So this is the thing. It's kind of like finding GCFs. You want the largest. So we got 1 and 48, 2 and 24, 3 and 16. That's why it pays to go in order. Anything else? 4 and 12. Anything else? I think that's it. Which combination has the largest perfect square? I see a couple that have perfect squares, but which combo has the largest? 16 times 3. And the reason we want that one is 16 is the largest perfect square. We could have gone with 4 and 12, but guess what? 12, we could still break it up into 4 times 3, and we would have had to have done that again. So it's a little more work if you don't find the largest perfect square. Okay, so let's use 3 and 16. Okay, so this becomes the square root of 16 times 3. And take it from there. What's our answer going to be? 4 times the square root of 3, or 4 radical 3. So the answer is 4 radical 3. Okay. Let's see about 300. 300. What's the largest perfect square? And so think of these numbers, right? Think of these numbers. We're hunting for these numbers. Oh, sorry, these numbers. Is 100? Yeah, it's 100 times 3, right? I think that's it. Sometimes we get lucky and find it right away. So the factors, we'll just say, are 100 times 3. So we're going to say the square root of 100 times 3, which simplifies to what? Yeah. And then we get 10 radical 3. Okay. Sometimes there's already going to, and this is going to happen sometimes if you simplify, but you didn't quite get the biggest one. So we have 2 radical 45. We want factors of 45. Just the 45. 9 and 5. Yeah, I think that's it. So the factors 9 times 5. So this is going to be 2 radical 9 times 5, which we can break that up into 2 times radical 9 times radical 5. And the square root of 9 is 3. So now what do we do with that 3? Yeah, because basically, I'm going to show you all the steps because this is notes, and we don't want to get confused in the notes. We get 2 times 3 times radical 5. So this is 6 radical 5. Okay? No, it's just one factor. It's just this is just a series of factors that are the factors are 2, radical 9, and radical 5. So it's not like distributing. It's just one of the one of 3 factors. Okay, we good with this so far? Okay, so here is number 7. Joe and Aubrey believe that their expressions below are already in simplest form. Circle the name of the student who is correct and simplify the expression of the student who is incorrect. So someone is not correct. So circle the one that is correct. So we got Joe and Audrey. Who is correct and who is not? You think Audrey's correct? Yeah, the other one should. Can we break up 153 if that's the case? So one way to do this, if you think 153, start dividing perfect squares into 153 and see if one of them goes into it. So take 153 and divide it by, some of these numbers, see if anything goes in there. Ooh, I already found one. Ooh, and I found another. Okay, I think so. First things first, Audrey is, since I did find perfect squares that divide into 153, Audrey did it correctly, obviously. But what numbers go into 153 that are perfect? 3 and 9. Which one do we want to use, 3 or 9? We want to use 9. You want the biggest one. Okay, so we're going to write this as 3 radical 9 times 17, I believe. Then we got to simplify it. Yeah, we got to circle the one that's correct. Yeah, that's Audrey. Yeah, circle the name of the student who is correct. It was already in simplest form. So obviously we got to fix Joe's here. Wasn't it 9 times 17 is 153? Okay, so now 3 radical 9 times radical 17. That becomes 9, so this is 9 radical 17. Okay, perfect. All right. I'd like you to try number 8 on your own. Check in with your table partner. All righty. So since we had to the find the square root of 40, 4 times 10 makes 40. That's the largest perfect square. 4 is. So we get 10 radical 10, 2 radical 10 inches. Okay. Ulysses simplified square radical 72 and got 3 radical 8 as shown. Explain why his answer is not correct and give the correct simplified expression. Let's take a look. What did he do? He did 9 times 8. Okay, I'll buy that. And then he ended up with 3 radical 8. And that's not correct. Main reason I see is, can we break up 8? Yeah, 4 times 2, right? So, yeah. So what number goes into 72 that is a larger perfect square than 9? What goes in to 72? What would have been a better choice than 9? 36 and 2. 36 would have worked, is the better choice. So square root of 72 could have been broken up into 36 times 2, which would have been square root of 36 times square root of 2, which would have been 6 radical 2. Because here we would still have to do that, right? Turn that into 4 times 2. Square root of 4 is 2. Multiply that 2 times 3, you get 6, which you have there. And then you'd have square root of 2 inside. So there it is. Yes. So the assignment is on Cami and on paper. Let me give you the sheet.